this is just to give you a practice problem, practice proof. Before we do that, I do want to remind you, just making sure I did cover this in class. In class, I'm like 99% positive that we did this proof together, but I want to make sure everyone understands what we're trying to teach in class is that once you prove this, and I think we proved this with like um, 4 or 5 lines in the proof. But once we do that, you don't have to prove it anymore. Given this information, in this case, given that angle 1 and angle 3 are congruent, you can say the overlapping angles, which would be CBD and EBA, what you're trying to prove, or sorry, DBC and EBA, are equal. That's just the overlapping, that's just the overlapping angles theory. So basically, if you are ever given this kind of a picture in a different proof and you're asked to prove something else and you're giving this information right here, you can literally directly go from this line, the first line, to the second line. And your reasoning is the overlapping angles theorem. It basically states that if you have these smaller angles and everything shares a vertex, the overlapping ones, which are this and this, have to be equal because 2 is going to be the same for both of them. So that's just a concept that, after we prove something, make sure you are writing down the name of the theorem so that you can use it in other proofs. Here's one that I don't think we're not really proving a specific theorem. In this case, we're just proving congruent triangles. So please excuse my notations. I'm going to do this by typing, but I can't get a lot of the notations that we have. So first of all, you would definitely, I'm not going to do that just in terms of room, but you would definitely have to write every one of these givens down in the statements, and your reasons would be given. Okay? And I'm going to go ahead and mark those up on the triangles. KR and PR. KRO is this angle right here, and this angle right here are congruent. So we have a side and an angle, and we're given angle 3 is congruent to angle 6. But we need to basically prove that 5 and 4 are congruent. So the first thing I'm going to say, and I actually don't need any of the givens for this, the first thing I'm going to say is that the measure, and I'm just writing 3 right now, but you should really write the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. And we could also say the measure of angle 5 plus the measure of angle 6 is equal to 180 degrees. And the reason for both of those would be linear pair property. It's funny, I didn't actually say this in the beginning of this video, but I'm hoping that some of you paused the video and tried this on your own. So at this point, if you haven't already, go ahead and pause the video, try it on your own, and then play the video. Okay? So we have all the givens, we have this, and basically we need to somehow get 5 and 6 to be equal. 5 and 4 to be equal. Well, the first thing I'm going to do is notice that they both equal 180, so that means they equal each other. So if 3 plus 4 equals 180, and if I switch this around to 180 equals 5 plus 6, that would mean that the measure of angle 3 plus the measure of angle 4 will equal the measure of angle 5 plus the measure of angle 6. And I did that because now I have an equation where the 4 and the 5 are on opposite sides, but they're in the same equation, which was great. That's what I wanted to do. And the reason for that is the transitive property. You could have also said substitution, but it's either transitive or substitution property. It depends on the order. If I would have switched this to 180 equals 5 plus 6, if A equals B and B equals C, then A equals C. That's the transitive property we learned in class. Now that you have 3 plus 4 plus 5 plus 6, I gotta somehow get rid of 3 and 6. Well, to get rid of 3 and 6, this is something you're going to do in many proofs, but maybe this is the first time you're seeing this. We want to basically write the same number on both sides. So instead of 3 plus 4 equals 5 plus 6, I'm going to write 3 plus 4 equals 5 plus 3. Now, why can I do that? I can do that because earlier in the proof, we said 3 and 6 are the same. So instead of a 6, I'm going to substitute in a 3. Now, the reason why we're doing that is you have 4 and 5, and you have 2 3s on opposite sides. Well, If this is true, if 3 plus 4 equals 5 plus 3, then I can automatically say the measure of angle 4 equals the measure of angle 5. But why can I say that? What did I do? I deleted or I took away a 3 on both sides. Well, you're allowed to do that in algebra. Why? Because you're subtracting the same thing on both sides. So that is the subtraction property of equality. Now, folks, I kind of ran out of room here, but here's the deal. We have an angle. Oops, sorry, it was this angle. We have a side that is included between the two angles. So based on this information and the given, I can now say that KRM is congruent to PRO, and the reason is the angle side angle theorem. Okay? And again, what you did right here, make sure, because it's something that maybe in the first time you do the first couple proofs, you didn't like kind of think about doing, but this is a very good strategy whenever you're trying to get two angles. In this case, I was trying to get 4 equal to 5. If you can write an equation where you have the same thing on both sides, well, you can just take it away. That's the subtraction property of equality. So that's the strategy that you want to kind of do for, you're going to be doing for a lot of proofs from this point forward. Okay? And again, we didn't prove any specific theorem. We just proved those two triangles congruent. Hope that helps.